Hello, Year 7, and welcome to another maths video. Today, we're looking at square and cube roots. Okay, now you may have heard of what a square root or a cube root is, but you might not fully quite know what it means or understand. So today, we're going to find out. So what is a square root? So let's look at this example over here. We have 3 squared. So remember, when we have something to the power of 2, it means we're multiplying it by itself twice. Okay, so 3 squared is the same as 3 times 3. It's not the same as 3 times 2, okay, which would be 6. It's 3 times itself. So there's 3 times 3. You've got 2 3's there, multiplied together, which equals 9. Now you can see here, there's this funny symbol. It kind of looks like the divide symbol that you might have used when you're doing division, but it's a bit different. It's got that little front bit here. So the way that we draw that is we go like that, okay? And so we're talking about the square root of 9. The square root of 9 is what we call that symbol. So when you see that symbol, it means square root. And what is the square root? Well, if 3 squared is 9, then the square root is 3, because the square root is what we call an opposite operation, or an inverse operation will be the words that you'll use later on. But every operation in maths has an opposite or an inverse, which sort of undoes it. So if you add 3 and then you take away 3, you're back to where you started. They're opposites. If you multiply by 2 and then divide by 2, you're back to where you started, because multiplying and dividing are opposites. In the same way, if you square a number and then square root that, you go back to where you started, because squaring and square roots are opposites. So when you're trying to calculate the square root, you got to think backwards. You got to think, what number multiply itself will equal the number under the square root sign? So what number multiplied by itself would equal 9? Well, we know 3 times 3 is 9. So the answer to the square root of 9 is 3. Okay, we're going to do a few more examples. So part A, we just did that. What number multiplied by itself equals 9? 3 multiplied by itself equals 9. What number multiplied by itself equals 25? So let's try a few. So 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. So the square root of 25 is going to be 5, because 5 squared is 25. Okay, remember, squaring just means multiply by yourself. Okay, part C, what number multiplied by itself is 16? Well, we just found that out. 3 times 3 is 9. 4 times 4 is 16. So 4 squared is 16. The square root of 16 is 4. Okay, we're thinking backwards. What number squared equals the number under the square root sign? All right, so that's how we find out square roots. What about, here's an interesting example. Okay, 3 cubed, or 3 to the power of 3. Okay, we know that 3 cubed is just 3 times 3 times 3. Okay, so you've got 3 3's all multiplied together. 3 to the power of 3 is 27. So the opposite of cubing or putting something to the power of 3 is going to be what we call the cubed root. Now this is similar to the square root, except we write a little 3 in the top left corner there outside of the symbol. And that means we're not square rooting, we're cube rooting, or as such. So when we have a number under the cube root sign, we're not just thinking what number multiplied by itself equals the number under there. We're thinking what number multiplied itself and then multiplied by itself again is going to equal the number under there. Okay, so we know that 3 cubed, 3 times 3 times 3 is 27. So that means the cube root of 27 is 3. Okay, again, the opposite operation. So here, what number multiplied by itself and then multiplied by itself again is going to equal 1,000? So we know that 1,000 has lots of zeros. So we're going to think of something around like 10. So if we had 100 times 100, that equals 10,000. Okay, that's too big. Let's try 10 times 10 times 10 again is going to equal, so it's 10 times 10 is 100, times 10 again is 1,000. So the cubed root of 1,000 must be 10, because 10 cubed, or 10 times 10 times 10 equals 1,000. So you're thinking backwards here. All right, the cubed root of 64. So something multiplied by itself again equals 64. Let's try a few ones. So we've already done 3 cubed. So 3 times 3 times 3 is 27. So let's try the next one, 4 cubed. 4 times 4 is 64. And then, 4 times 4 is 16. And then times that by 4. So the 10 becomes 40. 6 times 4 is 24. Add them together, 40 plus 24 is 64. So we know that 4 times 4 times 4 is going to be 64, which means that the cube root of 64 is 4. Okay, so it's a bit tricky, but we've got to think backwards to think what number multiplied by itself and then multiplied by itself again is going to equal the number under the cube root sign. Okay, now last question here, and this one is a bit funky. So we've got a really big number. Now this is going to be really hard to do just in our head. You can use a calculator for this, but in this topic, we're trying to find the nature of numbers. What makes up numbers to make them what they are? So we're going to do this without a calculator by using our factor trees. So let's split up our big number with a factor tree. It can divide by 2. So we're going to think, what is 1,764 divided by 2? What's going to be a bit more than 800? It's going to be a bit more than 880. It's going to be 882. Okay, the way I work that out is I know that 800 times 2 is 1,600. Okay, 80 times 2 is 160. And then 2 times 2 is 4. So that's how I work that out in my head. I can split this up into 2 again. I can circle my prime factors. And I get 4, 4, 1. Now this one, I can't quite split up by 2. So I've got to think, can I split up 441 by 3? Let's see. So it doesn't look like I can divide it by 3. Remember, oh no, because I can add up my digits. So let's say 100, it's going to be 140 plus 7. 147. You could do this using your little trick here. Remember, that's slightly different to a square root sign. So it goes in 1, but we've got 1 remainder. That goes in 4 times, and we've got 2 remainder, and then 7. So that's how we got 147 here. Now we're going to split up 147. So 2 doesn't go in, does 3? 3 does, because 7 plus 4 plus 1 is 12, which is divisible by 3. So that means that number is divisible by 3. So let's think 120 has 40 threes. And then you've got 27 more, which is 9 threes. So it's going to be 49. Again, you can confirm that yourself. And then 49, I know that 2 doesn't go into, 3 doesn't go into, 5 doesn't go into, but 7 does. In fact, 7 times 7 does. So now here is a funny example, because what do you notice about my factors? I've got 2 2s, I've got 2 3s, I've got 2 7s. So my prime factors Okay, I can write it like this. And this is where it gets interesting. I can change the order to be 2 times 3 times 7 times 2 times 3 times 7. So you notice here, I have two numbers. What's 2 times 3 times 7? 2 times 3 is 6. 6 times 7 is 42. Okay, times itself. So if I have a number that times itself to equal a number another, then I can say that the square root, therefore, remember 3 dots means therefore, 1764 equals, well, the square root of that is going to equal 42, the meaning of life. So let's confirm that. Let's check in our calculator. The square root of 764 equals, and what do you know? We didn't even need a calculator. So we can use factor trees as a way of finding square roots of numbers. All right, hope you enjoyed the video. Good luck with the questions today. Let me know if you have questions in the Teams chat, and I'll see you in the next video.